Hi guys, today we're going to use trigonometry to find area. This is a slightly more difficult lesson. Make sure you are paying attention. So just a reminder that you have to use SOHCAHTOA to do your trigonometry. And so for the first example, we're going to use isosceles triangles. This happens when you have a regular polygon and you're going to break it up into various isosceles triangles and use the central angle. So here it says, what is the area of a regular nonagon with 10 centimeter sides? So you're going to break it up into 9 triangles and they will all be isosceles. So n is equal to 9 and perimeter is going to be 9 times 10 because each side PR is 10. So you know your perimeter already, and the central angle is 40 degrees. However, you have to make half of the isosceles triangle. So this 40 degrees is, make sure you're not working off of 40 degrees. It's actually 20 degrees, which is half of 40 degrees. And we're going to use the apothem. We're going to use this half of PR, which is PS, which we are going to call a side, and CP is the radius of the polygon. So now remember that you're going to use only half of the central angle in all of these calculations. So we first try to find the apothem, and the apothem in this triangle, to find the apothem, it's opposite over adjacent. So tan 20 is 5 over A, and A is 5 over tan 20, and it's 13.7. Now, even though I've written 13.7, your calculator has the ability to keep the decimal, so try not to do any rounding till the very end. So you're going to then put it into the area formula. Make sure you write the formula first, and then again, you're just going to do it in the calculator. So whatever decimal you have times 90 divided by 2. And in the final answer, you're going to give me a whole number answer with the proper units. So it's 618 square centimeters. So I want you to try this one. Pause the video and try it. Remember that you are only going to use half of the side. And this is just one of the isosceles triangles that you can make in a regular pentagon. So pause the video and here you go. Let's see if you got it right. We have n is equal to 5 and the perimeter is 4 times 5, which is 20. And the central angle is 72. If the central angle is 72, then you should remember that this angle here is just 36. And so we're going to use 36 to find the apothem. We already know that the side is 2 because that's half of 4. And so the apothem is going to be 2 over A is tan 36. You're going to calculate, and even though again I have 2.8, you're going to keep the decimal and then use it in the area formula. And the answer is 28 square inches. Now the next question is a slightly more difficult because here, instead of giving you the side of the polygon, they are giving you the radius of the polygon. It is still a regular polygon, so you're going to split it into as many isosceles triangles as you can. In this case, a decagon means that n is equal to 5, and the radius here is 9.5. So here, not only do you have to find the apothem, you also have to find the side of the triangle, this bottom side. So the hint is to find S first. So let's start off by first writing down what we know. We know n is 10, but I can't find the perimeter because I don't know what S is equal to. And of course, I also have to find A. So the central angle is easy to find because it's 360 divided by 10. So we have 36. Now remember, in this triangle over here, this angle is going to be 18 degrees. So we're going to use 18 and first find S. That's my hint. You can find it in any direction you want, but you want to make sure you get to the right answer. So we have this as our sine formula. And again, I'm just putting a few of the decimal places. Remember, you can carry it in your calculator. Do not round anything. Just leave it in your calculator the way it is. So after you have found the side, you're going to multiply it by 20 because this is a 10-sided figure. And that is our perimeter. And now we find the apothem. And again, you're going to get some long decimal. You're just going to use your graphing calculator and do this with all the decimal places. No rounding. I don't want to see any work. I'm just happy if you write down this part for me and you write down this part for me. I'm happy. And then you're going to put it in the area formula, and the answer is 265. Remember to not round within the problem, round only in the final answer. All right. So the next thing that you have to know is how to use trigonometry if you don't have an isosceles triangle. However, you do have side angle side given. And this only works if the angle given is an acute angle. So here's a little bit of a proof. We have a triangle and H is the height from B to AC. So sine of A is H over C. Therefore, the height of the triangle is C times sine of angle A. And the area of the triangle is base times height divided by 2. So you can, instead of H, you can put C sine A. And this way, we can use trigonometry to find the area of any triangle, as long as you have a side, angle, side, and make sure it's an included angle. So you can write down the little theorem. Make sure you know that the angle that they're referring to is the included angle. So angle A is between sides B and C. So the question, the straightforward question is very easy. All you have to do is use the formula, and that gives you your answer. Remember to give me a whole number answer. But I want you to try this challenge question. I want you to pause the video, try it, see if you get it right. Okay, find the area of the shaded region. Okay, now you want to make sure you know how to write this nicely. So I have shaded area is the area of the larger pentagon minus the smaller area of the smaller pentagon. And keep your work organized. On the left side, I'm going to find the area of the larger pentagon. And on the right side, it will be the area of the smaller pentagon. So let's see if you got these right. I have my steps here. So the central angle is 72 because it's 5-sided. And if the central angle is 72, then the angle here is 36. And then you're going to use that to find the side. Well, the side is given, so you just have to find the apothem. And use that apothem to find the area of the larger pentagon. And on the other side, you're going to use the same steps and find the area of the smaller pentagon. This time the perimeter is 5 times 6. In the bigger one, it was 5 times 8. And the angle is still 36. And so A is 4 point something. And the area is 61, and shaded area is larger minus smaller. So the shaded area is 48 square centimeters. Now, another way to do this would be to find the area of the larger pentagon on the left, and then use the ratio of the areas. So we know that the scale factor is 6/8. So the ratio of the areas is going to be 36/64. And you just found the area of the larger pentagon. And so you can solve this and you get the same answer. Now you're going to do your subtraction. And the final answer is 48 square centimeters. All right, that's it for today. And I'll see you soon in class. Goodbye.